Alright, so let's do a quick little review of how would I solve an equation that has variables on both sides. So notice I have an example problem written up here. So what I want to do first is try to see if I can simplify each side of the expression. And here's where I'm going to combine my like terms. You guys are very familiar with this. So I'm just going to start on this side of the equation. I'm simply looking at this expression right here. So are there any like terms that I can combine? Well, notice my 7, or my constant, is the only one that's here. This is the only constant on this side. But notice, I have two numbers with the variable x. I can combine those because they're like terms. They have the same variable and they have the same exponent. In this case, it's an understood 1. So I can combine these two x terms on this side of the equation. So that's what I'm going to do first. So notice, and I want to be careful, I want to include that sign that's in front there. So what I'm going to do is I'm going to bring this 7 down. I didn't do anything with it. Then I'm going to combine those two terms. 3x minus 12x is a negative 9x. Then I look at this side of the equation. Notice this expression right here. There's no like terms. I have an x term and I have my constant. So I'm simply just going to bring that down. Now I've simplified both sides. Now here's my strategy. You don't have to do this, but if you're just starting out and you're sometimes still a little uncomfortable with this, once you get it to this point, once you've simplified it, where you have your constant and a variable term, constant and variable term, I like to always move my variables to the left. It doesn't bother me if I have to deal with positive or negative signs. I like to do everything the same way so I can have a routine. So if I have the opportunity, I'm going to move my variables to the left. And I would always start with your variables. So notice, I have a positive 3x. So the inverse operation of that would be to subtract 3x. And I'm going to do it to both sides of the equation. So I'm going to subtract 3x from both sides. And notice, when you subtract that 3x, put it under the like term. Don't put it under the constant because that's not a like term. You want to put it under the term that it's like. This has the variable x. This has the variable x. Those are what I'm going to subtract from each other. That simplifies to 0. I'm going to simply bring my 1 down. Here's my like terms. I got negative 9x minus 3x is a negative 12x. And I'm going to bring down my 7. So now I just have a two-step equation. It's not the order that I'm used to. I'm used to having a variable first and then the constant, but I still do the same steps. I'm going to start with my addition or subtraction first. This is the same as having a positive 7 or adding 7. So I'm going to do the inverse operation. I'm going to subtract 7 from both sides. And then 1 minus 7 is a negative 6. And then my last step is just to divide by the number or the coefficient in front of x. It's negative 12. So I'm going to divide both sides by negative 12. And you know what? Sometimes it's okay if you get a fraction. That simplifies, leave with my x, negative 6 divided by negative 12. A negative divided by negative is a positive. So I'm left with the answer of 1/2. So if I was to substitute 1/2 in for both of these variables on x's over here and did all the work, you would see that both sides would be equal to each other. So this is how you solve an equation with variables on the both sides. Look at each side of the equation. Start on your left side. Are there any like terms I can combine? Notice my right side simplified. Once you get to the point where you're just left with numbers and variables, start by moving your variable to the left by doing the inverse operation. And then your last step should be just to divide by the number in front of x. So that's how you would solve an equation with variables on both sides. Now I want to look at two more types of equations real quick. And this falls under the category of work smart, not hard. So let's look at this first example. I have 3x plus 6 equals 3x minus 4. What do you notice? Notice on each side of the expression, in front of the variable x, I have the same coefficient. Same number, same sign. Well, guess what? If I have the same number and the same sign in front of my variable on both sides, those would eliminate each other if I were to do the inverse operation. So really what I want to look at is the constant. Does 6 equal negative 4? And the answer is no. There is not a number that I can substitute in for x that's going to make this equation equal to each other. So this answer right here would be no solution. So it's a special type of equation. There is nothing that's going to make this expression equal this expression right here. So if you notice that they have the same number and the same sign in front of the variable and the constant is different, just stop right there. It's no solution. But I'll prove it to you. So let's just start. Let's move our variable to the left. I'm going to do the inverse operation, positive 3x. So that's minus 3x for both sides. Well, notice that cancels, but it also cancels here. So really what I'm left with is 6 equals negative 4. Does 6 equal negative 4? No, it doesn't, so that's no solution. So now let's look at one other special case. What if I have 4x plus 5 equals 4x plus 5? Now remember, if this side equals this side, it's true. So remember, if I were to substitute my answer that I got for x into the equation, and the left side said 6 and the right side said 6, does 6 equal 6? And that's true. That's how I can check to see if I have a right answer, because both sides equal each other. Well, the same logic or principle applies here. And in this case, it's just two expressions. But notice, 4x plus 5 is on this side, 4x plus 5 is on that side. Does this side equal that side? And the answer is yes. They have the same number and same sign in front of the variable, and they're both adding 5, the same constant on both sides. This expression is indeed equal to this expression. So your answer would be all real numbers are infinite solutions. So there's really no reason to work this out once you recognize that they are in fact the same expression on both sides. So this would just be all real numbers. So those are two special cases I just wanted you to see.